Hi class, this is Mr. Morris. I'm making an instructional video on atomic structure notes. It's really important that you take notes as you go along. This will be part of your binder check. Also, we're going to have a quiz over this when I get back. So since I'm out today, I'm just making it a video. These are topics that I think you can understand as long as you're listening, watching, following along, taking notes, and then when we're done, I want you to work on the practice. So let's get started. As with all notes, I want you to put your name at the top. You're going to put my name, you put your name. And then, of course, you could put your class period there if you would like. I'm not going to put the number up here, but the next number in your table of contents, and I can let you know for your particular class what that number would be when I get back in the classroom if you're not sure. But just look at your table of contents and add these notes to your table of contents. Okay, we have three main subatomic particles, the small particles that make up the atom. And yes, this is a new unit talking about the atom. So the three parts of the atom, I hope you remember them. They are the proton, neutron, and electron. Probably review for you, but if not, that's okay. We're going to go through it. The symbol for the proton is going to be lowercase p with a plus sign. For now, we'll talk about a more complicated symbol in the second semester. The neutron is lowercase n with a 0 for now. And then electron, p with a negative sign. Their charges, you've probably heard that protons are positive, neutrons are neutral, and electrons are negative. That's true. We're going to put numbers with them. So +1, 0, and -1. And their location, that means where do you find it in the atom? What part of the atom are they in? The proton is in the nucleus. The neutron is in the nucleus, which is the center of the atom, of course. The electron is the one that's somewhere on the outside. So there's a couple different ways we can talk about it. We could call it the orbit or the orbital. We could call it the electron cloud. That's probably the most common one. Electron cloud. Probably the most up-to-date way of explaining it. Okay, and we could write the exact mass in grams. This is not something I want you to memorize, but it's a good thing to go ahead and write down just to make an important point. So again, these are not numbers that I want you to memorize, but let's write them down. The mass of a proton is about 1.673 times 10 to the negative 24 grams. So that's a really, really small mass, right? Okay, the mass of a neutron is 1.675 times 10 to the negative 24. Now you notice the same power, very close to the same number. Which one weighs more? Well, it would be the neutron by just a little bit. Not much at all. And then we have the electron, which is 9.109 times 10 to the negative, not 24th, but 28. That's a pretty huge difference. To give you an idea, an electron is about 5,000 times smaller than a proton or neutron. Okay, so this one is the largest. This is the second largest. And this is the smallest by far. So what I want you to know is that the mass of proton and neutron is almost the same, but the neutron has a slightly greater mass. Okay? So neutron has a slightly greater mass. Make sure you know that. So write those out so you know which one is the heaviest, which one is the lightest. Okay? But when we're writing the mass, these masses I do want you to know. I want you to memorize these because it's just three numbers you need to know. You need to know, well, actually just two. Protons are 1 AMU. Neutrons, they're so close to the same that we say they're 1 AMU, atomic mass unit. And electrons, they're so close to nothing that we put 0 AMU. So that's the basics of what protons, neutrons, and electrons are. We're going to be talking about this because we're talking about atoms, and of course atoms are made up of protons, neutrons, and electrons. Right now we're going to focus mostly on the nucleus. But let's draw on this diagram down here before we move on. Okay, if you look here, the dark gray particle in the middle, well, there's no sign written on it, so that one looks like it's neutral. That's a neutron. Okay, then we have this one right here. Well, it's got a positive sign on it. That's a proton. And then on the outside, in the electron cloud, with a negative sign, is the electron. Okay, and then if you were to look over here, you got a little bracket around the protons and neutrons. That's just showing us what the nucleus is. As I said, in this unit, the first unit of atomic structure, we are really focusing on the nucleus. We're also going to be learning a little bit about how to use the periodic table. So if you have your periodic table, you can pull it out and look. You've got a nice little kind of map of what these different parts of your symbol on the periodic table represent. So we have the atomic number, the symbol, the atomic mass, and the name. So let's label it right here. We have the atomic number. Sometimes I just write the little number sign instead of putting the word number. You can do that if you want to. Na is the symbol. Sodium, that's the name. And this is the mass, the atomic mass, but we're going to put the word average atomic mass. And this is where we get into something that's different from what you learned in middle school. And it's very, very, very important that you understand this difference so that we don't make mistakes. Okay? I want you to write this down right here. Atomic mass does not equal, that means it is not the same as mass number. We're going to talk about mass number in a little bit. And most of the time in middle school, you learn to kind of equate these as the same thing. They are not the same thing. We can no longer think that way. Okay? So we're moving past this. We're moving on to talk about specific exact atom names. So make a little break in your page there, and then let's go down here. The complete name of an atom. The complete name includes the name, then a dash, and a number at the end. That number is the mass number. Now let's look at the complete symbol. Well, it has the symbol. We have two numbers on the left. You notice that that number is the same as this number. That's because it's also the mass number. This number at the bottom is the atomic number. Okay, so now that we've established how we write the complete name and the complete symbol, again, the number after the dash or at the top left of the symbol is the mass number. We need to define what these terms mean. The atomic number is the number of protons. It's also, for now, the number of electrons. Later we'll talk about a different case, but for now, because all of the atoms we talk about are neutral, it's also the number of electrons. That will change later. Another thing that you need to know about it is that this is the way that we can tell what an element is. So in other words, the atomic number determines the identity of the element. So we find that you can have a different number of neutrons, but you can't have a different number of protons without it being a different element. So anything that has 3 protons is by definition lithium. Lithium, by definition, always has 3 protons. If it has 2 protons, it's not lithium anymore. It's helium. The number of protons tells you what element you have because it's the atomic number. If you look at the periodic table, it makes sense. They all have different atomic numbers. That is the number that actually determines what the element is. It's the number of protons. Now the mass number is different. The mass number can change. Mass number is the number of protons plus the number of neutrons. It is actually the mass of the nucleus. And it's a really useful thing to look at. The mass of the nucleus is protons plus neutrons. Sometimes we need to find the number of neutrons. So I want you to write this down here. The number of neutrons can be found by taking the mass number minus the number of protons, or minus the atomic number. All right, at this point I'm going to show you just a couple questions from the worksheet that you've got. You're going to work through the rest of these independently and have it done before I get back on Wednesday. So when you're looking at this, be very careful. Like we said, the atomic mass is not the same as the mass number. So when it asks for the mass number, you do not look at the periodic table. The atomic number is the only time you look at the periodic table. Is when we're dealing with the atomic number. We don't do that for the mass number. The mass number needs to be figured out by using the information in this table or in the problem. So what we know now is it's helium and it has 2 neutrons. That's all that I know. So what I can do is I can find helium on the periodic table. Let's do that real quick. Helium is right here. It's He and it has an atomic number of 2. So I can put the atomic number down. Ignore the average atomic mass for now. We are not using that number at all in this lesson. Only use the atomic number. Okay, so that is atomic number of 2. The atomic number also tells me the number of protons and the number of electrons. Now, if I want to find the mass number, we could look back at our notes. How do we find the mass number? Mass number equals the number of protons plus the number of neutrons. So now that I have that, I can do protons plus neutrons to get a mass of 4. I could also finish my symbol. And by the way, if you only put the name and you don't put the mass number afterward, or if you only write the symbol and you don't put the mass number at the top, you will get a very low grade on this. It's very important you put the mass number. So we put helium, and then after that dash, we're going to put whatever the mass number is. It's 4. This is a helium-4 atom. It's a specific type of atom. We're going to talk more about that in class tomorrow. Okay, now the symbol, we need to write that. The symbol for helium is He. We also know the atomic number, which goes at the bottom left. And we now know the mass number, which goes at the top left. Helium-4 is the atom we're talking about. Okay, now we have magnesium, Mg25, so we know that's magnesium. And if you're not sure, always check, so we can go look. Mg is right here, it's magnesium. And use your own periodic table on these. or you can borrow one. Magnesium, and that number right there is the mass number, so we're going to put 25. Now we should look at magnesium. The atomic number is 12. So we're going to put 12 down here and write it in where it says atomic number. The mass number comes from after the dash. It's 25. Protons are always going to be the same as the atomic number, and so will the electrons. So now we just got to figure out how many neutrons do we have. So how do we find how many neutrons we have here? Well, if you look at your notes, we wrote it at the bottom. Neutrons are equal to the mass number minus the atomic number, which makes sense. If the mass number equals protons plus neutrons, to find neutrons, you do mass number minus the number of protons, or minus the atomic number. So mass number minus number of protons. 25 minus 12 is 13. You can use a calculator if you want to. Okay, we'll do one more, and I'm going to do it quickly, and then we'll be done, and you can do the rest. Okay, so 30 is the atomic number. I can look for 30 on here and find out what element it is. It's zinc. So we're going to put zinc, and I'm going to put dash to remind myself that I need to write in the mass number. Zinc is Zn, and the atomic number is 30, so I'm going to put 30 right there. Okay, I have 35 neutrons. Okay, well, I don't know the mass number yet, so I need to just start copying down. 30 atomic number is also 30 protons, 30 electrons. Okay, 35 neutrons, 35 protons. Add those together, you get 65 for a mass number. So now I can write 65 here, and I can write 65 here, and there you have your first 3 examples. So use your periodic table, use a calculator if you want to, try to finish this worksheet out. We'll have more practice to come as we go through notes tomorrow. Have a good day.